jadi din kan one
check 1 2 3 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 is it loud and clear? Right. Check 1. Everybody is loud and clear, and you can hear clearly without any disturbance. Now is it okay? No echoing, no screeching, nothing, no? Right, okay. Right. Good evening, everybody. Welcome to another edition of Final Countdown. This is week number 5, day 1. Week number 5, day 1. Right. We'll get into work quickly. Today we'll be discussing 2004 A-level question. 2004 A-level question paper. Right. Have a look. In the following expression, I and V represent voltage and current respectively. C is a constant. What does KT over Q have? Have a look. Now we know this is going to be a value. This is also going to be a value. So the other part there also should be a value. So I can rewrite this V over KT over Q. So how can I make this a value? If this is also voltage. Finished? If this is also voltage. So KT over Q will give you dimensions of voltage. Dimensions of voltage. Okay? Dimensions of voltage. Therefore, directly there, answer is answer number 5. Answer is answer number 5. Right? So very simple. If this is a value, this is a value, left hand side value, right hand side also value. So kV over KT means KT divided by Q. If this is voltage, then this part also should be a voltage. Right. Moving on. Consider the following statements made regarding electromagnetic waves propagating in a vacuum. Electromagnetic waves are transverse waves, correct. Speed of an electromagnetic wave is independent of the wavelength. Speed of the electromagnetic wave is independent of the wavelength, correct. Remember, speed of electromagnetic wave depends on 1 over mu naught epsilon naught square root. Does not depend on other properties except for the properties of mu naught and epsilon naught. Properties of a magnetic field and electric field. The electric and magnetic fields associated with the wave are always directed along the direction of propagation of the wave. Wrong. Electric and magnetic fields are perpendicular to the direction of propagation. So here you have, let's say, electric field. Here you have the magnetic field. Here you have the propagation. So if I draw this for you separately, electric field will vibrate perpendicularly. Magnetic field will vibrate perpendicularly to the direction of propagation of the wave. Okay. Direction of propagation of the wave. So from this we can say A and B correct. A and B correct. Okay. No? From this we can say A and B correct. A and B correct. Right. Next one. Have a look. Next one. For the given distance time graph, the magnitude of the velocity is, right. Okay. Now here gradient is 0, velocity is 0. Positive gradient, positive velocity. Negative gradient, negative velocity means going backwards. Here also positive gradient, positive velocity. But which has the bigger gradient? This has the bigger gradient. So maximum is at D, minimum is at A. Maximum is at D, minimum is at A. So your answer is answer number 3. Answer is answer number 3. Okay, no? Right there. Gradient of ST graph. Gradient of ST graph gives you velocity. Greater the gradient, greater the velocity. Greater the gradient, greater the velocity. Right? Okay. Next one. a frame is made by joining these uniform rods PQR having identical geometrical dimensions. P and R have the same mass. So here you go. Here mass m, here mass n. Here double the mass 2m. If I join this 1:1 ratio 2m, again 1:1 ratio, center of gravity is at the center there, right? Center of gravity is at the center there, right? So if you hang something, the vertical line should pass through the center of gravity. The vertical line should pass through the center of gravity. Vertical line should pass through the center of gravity. So the most suitable, I think the most suitable is answer number 2, right there. In equilibrium, when we hang a particular object, the vertical line from the point we hang, should pass through the center of gravity. Right? Moving on. Okay. When an object is made to perform simple harmonic motion, the force acting on the object is proportional to the magnetic displacement from the equilibrium position. So what's the rule? F is proportional to minus x. Force acting on the object is always directed away from the equilibrium position. Frequency of oscillation of the object is proportional to the amplitude of the oscillations. Total energy of the object does not depend on the amplitude. Potentiality of the object is always constant. Fifth one is wrong, fourth one is wrong, third one is wrong, fourth one is wrong. So here is what you can get. So remember, force is proportional to the displacement and the force is always directed towards the center of oscillation. There, center of oscillation. So fifth one we can say answer is answer number 1. Fifth one, answer is answer number 1. Right. So if you talk about the total energy is equal to half m omega square a square. If you talk about the potential energy is equal to half m omega square x square. There you go. Okay. These are your relationships. Right. Moving on. Consider the following statements made about light passing through a prism. Frequency of the light changes in passing through the prism. Wrong. From medium to medium, frequency won't change, but wavelength and velocity will change. Light of different colors travel at different speeds inside the prism. Correct. Blue light deviates more than red light when passing through. Correct. B and C correct. Okay. B and C correct. Moving on. The most appropriate fuse for a heater 1 kilowatt connected to a main household electric supply is how much? So power is equal to VI, don't forget. Power is 1 kilowatt 10 to the power 3 watt. Home supply 230 volts I. So here 1000 divided by 230. 1000 divided by 230. Right? So if you do the basic simplification, 1000 divided by 230 you will get 1000 divided by 230 you will get 4.37. Okay. 4.35 amperes. 4.35 amperes. Right. Now, if you look at this carefully, so So if you use 4 before this is reached, it will break. So the most probable fuse is going to be the 5 ampere fuse. So it makes sure that bigger currents don't pass through. Bigger currents don't pass through. Clear? Right there. This makes sure that a current bigger than 5 ampere will never pass through the electrical instrument. A current bigger than 5 ampere will never pass through the electrical instrument. The fuse will melt, saving the electrical instrument. The fuse will melt, saving the electrical instrument. Right. Total electric power generation capacity in Sri Lanka is 2.1 gigawatt. If this power is to be generated by using converting mass to energy, Einstein's equation, E is equal to mc square. Here, mc square. I divide this side by time, this side by time, this becomes power. Power means 2.1 gigawatt. Giga means 10 to the power 9 watt. Here. How much mass per second should be converted? So speed of light 3 10 to the power 8 whole thing square. A simple work. 2.1 10 to the power 9 divided by 9 10 to the power 16. 9 10 to the power 16 m over t. Look at the board. 3 times 0.7 over 3. Simplify this, 10 to the power minus 7. Here 0.233 10 to the power minus 7. Simplify this, 2.33 10 to the power minus 8 kilogram per second. Right. If you look at this, kilogram per second is not there, 10 to the power 3. 10 to the power 3 there, 10 to the power minus 5. 0.023. 0.0233 10 to the power minus 3, that's milligram per second. Milligram per second. There you go, answer number 1. Answer number 1. So pretty simple connection. So energy converting, or E is equal to mc square. Mass is converted to energy. I divide both sides by time, converting this to power. Converting this to power. Okay? Right. Question number 9. Question number 9. A horizontal force 10 Newton is applied for a period of 10 milliseconds on a body placed on a smooth horizontal surface. What's the change in momentum? Force into time is change in momentum. Can you see? Force is 10 Newton, 10 millisecond. 10 millisecond. Change in momentum. Look at this carefully. 0.1 kg ms minus 1. Your answer is 0.1 kg ms minus 1. That's your change in momentum. Right. Moving on. An object lies on a horizontal surface. When the object is pulled horizontally, the horizontal force increases uniformly. The radiation of friction force, famous graph. All of you all know correct answer is answer number 3. Linear radiation. Here at this point it reaches limiting friction. Limiting friction, Fs max. This part is static. This part here is what? Dynamic. Static and dynamic. Clear? Static and dynamic. So these are all very simple things. You can't get it wrong. Quickly you have to answer and finish it. Clear? Quickly you must answer and finish it. Attack it with all your mind. Finish it all. Right. Question number 11. Question number 11. A thin glass of refractive index 1.5 is immersed in water. Now, water refractive index, don't forget 4 over 3, 1.3. Glass refractive index 1.5. 1.5. Okay. Which of the following ray diagrams is wrong? So if you take this part, this is like a prism. Top part of the prism. Top part of the prism. Look at this carefully. Light rays are moving here. Light rays are moving here. So rarer denser. Rarer denser means it should go towards the normal. Then denser, rarer, it will go away from the normal. So away it will go. This one, bottom part of the prism. Bottom part of the prism. Right. If you look at this carefully, here you go. Rarer, denser towards the normal. Denser, rarer away from the normal. So going towards, there is an issue. There is an issue there. Right. Look at this one carefully. Here, rarer, denser towards. Rarer, denser towards. Have a look. Rarer, denser towards. Denser, rarer away. So here away. That is also possible. Take the bottom part. Rarer, denser towards. Denser, rarer. Or here towards. Denser, rarer away. Draw this again. Here. Have a look. So light ray is coming somewhere here. Rarer, denser towards. Small deviation. Towards. Denser, rarer away. So denser, rarer away means this will push it away slightly. This one going through the center undeviated, correct. Now this can't come towards, no? It should go away, no? It can't come towards, it should go away. So what are they asking? Which diagram is wrong? Which diagram is wrong? Right. Which diagram is wrong? So thin glass refractive index 1.5. So the denser surrounding is rare. So rarer, denser towards. Denser, rarer away. So it should go away. Here it's coming towards. Here it's coming towards. Right. So guaranteed 1 and 5 is correct. The rest only you have to check. Rest only you have to check. Right. So from this, what can you say? Obvious, no? So this is your issue. Second one is the issue one. All the others should deviate away. This is coming towards. So correct one is the second one. Incorrect one. Wrong one is that. Wrong one is that. Okay, no? So looking at it, the easiest way is that. So if you want, you can draw it like this. Or is there another method to solve this? Yes. There is one more method to solve this. Draw the rays going through the optical center. Draw the rays going through the optical center. Right, you will get a better idea. If this is diverging away parallel to this through the optical center. Yeah. Going away, right. Here coming towards it, can't come towards it, should go away. This one is wrong. So this is your correct answer. So here also diverging away, correct. Here also diverging away, correct. So your wrong one is this. Answer number 2. Answer number 2, right. Next one. A certain person cannot clearly see objects located beyond 1 meter. Can't see beyond 1 meter means what? Can't see beyond 1 meter means what? Short-sighted or long-sighted? Short-sighted. Right. So here you go. The far point of the eye is 1 meter. Far point of the eye is 1 meter. Okay. Right. This defect can be corrected. So how do you correct it? But make sure infinity can be seen. Light rays coming from infinity should form the image there. Should form the image there. So image from the lens is object for the eye. 1 OV minus 1 OU equal 1 OF. Correct. 1 OV minus 1 OU equal 1 OF. Object is at infinity, image is formed at 1 meter. Focal length of the lens is equal to plus 1 meter. Plus 1 meter means concave lens. Answer number 1. Answer number 1. Right there. If the person cannot see beyond 1 meter, it means he is short-sighted. If the person cannot see beyond 1 meter, it means he is short-sighted. Right. Therefore, to correct the vision, we must use a concave lens. To correct the vision, we must use a concave lens. And infinity must be formed. And infinity must be formed. And infinity must be formed at the far point of the eye. At the far point of the eye. Okay. Right. Among the following, identify the quantity which increases with temperature. So resistivity increases with temperature. Surface tension reduces with temperature. Surface tension reduces with temperature. Surface tension reduces with temperature. Relative humidity of a closed room, RH is equal to M over Ms. Relative humidity, when temperature increases, Ms increases, RH reduces. Resistivity of a piece of silicon, be careful. Temperature increases, more electrons are there. More electrons are there, conductivity increases. This is a semiconductor. Semiconductor. Temperature increases, resistivity will decrease. Temperature increases, resistivity of a semiconductor. Semiconductor will decrease. Viscosity of water. Temperature increases, viscosity eta will reduce. So I can easily say resistivity of a copper wire. That's it. Resistivity of a copper wire. Okay, no? Right. Which of the following responses contains false information regarding photons and electrons? Photons cannot travel at different speeds in a vacuum. In a vacuum it travels at the same speed, right? Can have different energies, yes. Can be deflected by electric fields. Remember, photons have no charge. You can't deflect it. Can behave as particles and waves. Can behave as particles as wave-particle duality. Can eject electrons or materials. Yes, photoelectric effect. Cannot travel, these also correct. Electrons can travel at different speeds in a vacuum. Can travel at different speeds in a vacuum. Right. Can have different energies. Can be deflected by electric and magnetic fields. Correct. Can behave as particles and waves. Correct. Can eject photons from materials. Yes, X-ray formation. Right. Can travel at different speeds in a vacuum. Can travel at different speeds in a vacuum. Can have different energies. Yes, can be, depending on the potential difference, kinetic energies will change, field will change. So one mistake is there only in answer number 3. One mistake is there only in answer number 3. Okay now? Right. Right there. Photons have no charge. Photons have no charge. Therefore, they cannot be deflected in an electric or magnetic field. Therefore, they cannot be deflected in an electric or magnetic field. Right. The magnitude of the magnetic force acting on a current carrying straight wire. Magnitude of the magnetic force is Bill sine theta. Bill sine theta. Depends on magnetic flux, current, length, and the angle between the magnetic field and the wire. First one is correct. Very simple. First one is correct. Right, nice. Right. Right, okay. What did I press? Content. Right, okay. Now look. In the circuit shown, the current through 50 ohm resistor is. Current through 50 ohm resistor is. 50 ohm is here. Be careful. Now, when you solve this, don't be in a hurry, just think carefully. If you think carefully, you can get a better answer. Some of you are going to apply Kirchhoff at once. Don't go and apply Kirchhoff at once, think a bit. Okay. Now, this is connected here. This is connected here across 25, 25, 25, 25. So, I'll mark the battery. Positive terminal is connected across two 25s. Right? Positive terminal is connected across two 25s. Negative terminal is also two 25s. Negative terminal also across two 25s. 25, 25. Are they meeting? Yes, they are meeting together. This end and that end are meeting. That end and that end are meeting. So they are meeting together. What about 50 ohm? Positive end, end of one positive. Positive is there, both positive ends here, 50 is there. Look at it carefully. Here, positive terminal here, positive terminal there. The opposite of the positive. Positive terminal opposite is connected here. Positive terminal opposite is connected there. Across that we have 50 ohm. Right. Tell me, what kind of bridge is this? What kind of bridge is this? Wheatstone bridge. 25 divided by 25 is 1. Here 25 divided by 25 is 1. What's the current through 50 ohm? 0. 0 current, answer number 1. 0 current, answer number 1. Right there. We can redraw this as a Wheatstone bridge. We can redraw this as a Wheatstone bridge. Here, positive terminal one end, positive terminal other end. One end, other end. Opposite end and the opposite end are connected. Here, opposite end and opposite end are connected by 50. Negative side 1 and 25. Negative side 1 and 25. Negative side 1 and 25 here. That end is connected to the 25 there. The other end is connected to the 25 here, right? So there you go, Wheatstone bridge. Wheatstone bridge. Okay. Right. Which of the following procedures does not increase the accuracy of the indicated measuring quantity? Does not increase the accuracy. That's the key word. Period of a simple pendulum. Measure time for several oscillations. Yes. Increases the accuracy. Thickness of a plate of a uniform thickness. Measure thickness in the micron screw gauge instead of the vernier caliper. So accuracy means smaller least count, smaller fractional error. Smaller fractional error means greater accuracy. Correct. Diameter of the wire. Take several measurements at different positions. Yes. Balance length of a potentiometer wire. Insert a high resistance in series with the galvanometer. So why are you inserting a high resistance in series? Is it to increase the accuracy? No. To stop current from passing through the galvanometer. Simple. Current in a circuit. Use an ammeter having smaller internal resistance. Good. Smaller internal resistance means smaller potential difference. Now here they are telling you which is not. Which is not. So actually this is the reason. I am connecting a high resistor in series to stop a large current from going through the galvanometer. Right? That has nothing to do with the accuracy. Okay. Right. Question number 80. Three wheels A, B, C, same mass, same external radius, are made from uniform sheets. These wheels are released simultaneously from rest, from the same height on top. The wheels roll down without slipping. In order they will reach the bottom. Smaller moment of inertia, lesser time. Time is inversely proportional to, time is directly proportional to the inertia. Actually square root of inertia, it's okay. Inertia small, time is less. Inertia large, time is more. Right. So which has the greater inertia? IA is larger than IC, larger than IB. So which will reach the first one with the smaller? B, C, A. Correct answer is answer number 2. Right there. The time taken to reach the bottom. Depends on the moment of inertia. Depends on the moment of inertia. Smaller the inertia, lesser the time taken to reach to the bottom. Smaller the inertia, lesser the time taken to reach the bottom. Larger the inertia, greater the time taken to reach the bottom. larger the inertia, greater the time taken to reach the bottom. Okay. So here, smaller inertia, lesser time, large inertia, more time. So here, greater inertia, second greatest inertia, smallest inertia. So it means closer distribution. So who will reach the bottom first? B, C, A. Correct answer number 2. Right. A flow system consists of manometer tubes A, B, C is shown in the figure. Water is flowing at a constant rate. The heights of water levels. So all of you all know smaller area means larger velocity. Larger velocity means smaller pressure. Smaller pressure means smaller height. Large area means smaller velocity. Smaller velocity means greater pressure. Greater height. Now, second bigger one. So velocity is slightly lesser means pressure is, height is slightly more. Here area is slightly less. So greatest height is at B, then D, then A, finally C. BDAC. BDAC. Correct answer is answer number 5. Right there. Smaller the cross-sectional area, greater the velocity. Smaller the cross-sectional area, greater the velocity. Greater the velocity, lower the pressure. Greater the velocity, lower the pressure. And larger the area, smaller the velocity. Larger the area, smaller the velocity. Smaller the velocity, greater the pressure. Smaller the velocity, greater the pressure. Okay now? Right. Work done during cyclic thermodynamic process. Now you all know clockwise cycle means network output. So these things you should remember. Clockwise cycle means network output. Network output. Anti-clockwise cycle means network input. Network input. What else? Internal energy change cyclic process is what? 0. Right. Work done. Here anti-clockwise cycle, area under the cycle or inside the cycle. So clockwise cycle, network output half base into height 3 PV. Clockwise cycle, network output 3 PV. 3 PV is answer number 3. Okay no? So there you go, the MCQs. Now you are experienced. The experience is making you do this much more quickly and easily. Clear? Quickly and easily. Right. Next one. So you can see a micrometer screw gauge. Name the parts of the micrometer screw gauge here. Right. What can you say? A. Sleeve. B is circular scale. C is going to be thimble. D is going to be a ratchet screw, or we can say ratchet knob, ratchet screw or ratchet knob. Okay. Now remember, this year they also gave this for main scale also they gave. But in reality the arrow indicates sleep. Right. Okay. Next one. What is the least count of the above micrometer screw gauge? Least count is equal to pitch divided by number of circular scale divisions. Number of circular scale divisions. Go back. Pitch is the distance between two linear scale divisions, 0.5. Number of circular scale divisions, 50. So from this we can say 0.5 divided by 50, 0.01 millimeters. 0.01 millimeters. Write down the scale reading of the diameter of the ball. Scale reading of the diameter of the ball. Diameter here is given. Where is it? 5, 5.5, 6. 6 and 46, 47, 48. Simplify it. Reading equal linear scale plus circular scale. 6, 48 into 0.01, 6.48 millimeters. 6.48 millimeters. millimeters. Figure 2 shows situation where micrometer screw gauge is adjusted to determine the zero error, right? Tell me, circular scale is above the linear scale. Are you reading more than the actual value or less than the actual value? So actually what happens is you're rotating this anti-clockwise. Here to here the measurement disappears. You're reading less than the actual value. If you're reading less than the actual value, these are a negative zero error. So your negative zero error is going to be negative total number of circular scale divisions minus division in line 47 into least count minus 0.03 millimeters. What is your correct reading? Correct reading is 6.48 millimeter plus 0.03, 6.51 millimeters. There you go. Negative zero errors are added right there. If the circular scale 0 is above the linear scale line, this is your linear scale line. Linear scale line. If the circular scale 0 is above the linear scale line, circular scale 0 is above the linear scale line, we say there is a negative zero error. We say there is a negative zero error. There you go. That's how you find it. Total number of circular scale divisions minus the division coinciding. Minus the division coinciding. That you multiply by the least count, you can get the zero error. And negative zero errors, are you adding or subtracting? Adding. Because you are reading less than the actual value. Okay, no? Right. So 6.51 is the value. 6.51. Write down the fractional error in the measurement. So fractional error is, don't forget, error divided by the reading. Now reading means the correct reading. Error is the least count 0.01, 6.51. 1 divided by 651. There you go. What is the precaution taken in the micrometer screw gauge to avoid overpressing of the object? What do you do? We rotate using the ratchet screw. We rotate using the ratchet screw until a click sound is heard. Okay, let's say we rotate using a ratchet screw. We rotate using a ratchet screw until a click sound is heard. Until a click sound is heard. Right. A wire of circular cross section L55, diameter 4 mm is fixed to the disc diameter D2 5 and thickness T equal 3. Magnitudes are given in parenthesis. What are the measuring instruments? L55 means guaranteed meter ruler. No question there. Meter ruler. D1 is 4 mm. D1 is 4 mm. So micrometer screw gauge. Micrometer screw gauge is good. Next one, D2. D2, bigger thickness. Vernier caliper. Vernier caliper can be used there. Thickness T again. Micrometer screw gauge. Micrometer screw gauge. Don't write MSG. Correctly write micrometer screw gauge. Micrometer screw gauge. Right. What experimental procedure would you follow to obtain a better value for the thickness? So what do? Measure the thickness at many locations and find the average. Measure the thickness. Measure the thickness at many locations and find the average. And find the average. Measure the thickness at many locations and find the average. Right. The thickness of a certain type of polythene sheet is much smaller than the least count of the micrometer screw gauge. Propose a suitable method to estimate the thickness. What do? Take many sheets of polythene, put it together, measure the total thickness and divide by the number of sheets. So take many sheets, put them together, measure the thickness and divide by the number of sheets. Right there. Take many sheets. Take many sheets. Put them together and find the total thickness. Put them together and find the total thickness. And find the total thickness. And divide it by the number of sheets. And divide it by the number of sheets. So correct, no? Divide it by the number of sheets. Right. So these are also done. Moving on. A small ball of mass 0.1 kilogram is dropped from rest. That means falling under gravity. The ball was initially at the height h from the floor. From the floor height h. Falling from rest. And bounces back after every collision. Figure shows a portion of the VT graph. So it collides, you can see here, collides with the floor with a velocity 30, right? What's the height? What's the height? So you can actually take area under the graph or you apply equations. V squared equal U squared plus 2AS vertically downward. Final velocity is 30 squared initially from rest. Acceleration under gravity into h. 900 equal 20h. Therefore, h is equal to how much? 45 meters. H equal 45 meters. Next one. Change in momentum of the ball. Change in momentum of the ball. And the momentum transferred to the floor at the first collision. Look at the picture. Colliding with 30, rebounding with 20. So it's colliding with 30, rebounding with 20. Rebounding with 20. Simple work. So change in momentum, change in linear momentum, change in linear momentum, how do you say? Change in linear momentum is final momentum minus initial momentum. Final momentum minus initial momentum. 0.1 into 20 upwards, 0.1 into 30 downwards, 2 upwards minus 3 downwards. Bring all vectors in the same direction. Multiply vector by negative direction changes. 5 kg ms minus 1. 5 kg ms minus 1. 5 kg ms minus 1. So these on the ball. These on the ball. On the flow, what can you say? Momentum change. 5 kg ms minus 1 downwards on the flow. 5 kg ms minus 1 downwards on the flow. Right? The value of T for the second collision. Let me read the first collision. No. Read the first collision. No. Second collision is here. This time. So you have to find the first time and the second time. Okay, no? Don't forget. You must find this time plus that time, then is the total time. T equal naught is measured from here. Right. So you must work the problem carefully. So S equal ut plus half at squared vertically downwards 45 starting from rest 10 t squared. T squared 5 means 9. T is equal to 3 seconds first case. Then projecting with 20, it will come and collide also with 20. S equals ut plus half at squared vertically upwards, going up. Going up, coming down, vertical displacement 0, 20 times T1 minus half 10 T1 squared. Simplify this. 0 equals 20 T1 minus 5 T1 squared. 5 T1 common, 4 minus T1. T1 equals 0, T1 equals 4 seconds. So total time is 3 seconds first, 4 seconds now. Altogether how many seconds? 7 seconds. Altogether 7 seconds. Right? 7 seconds. Okay. Right. Once you need it, write it down. These are not difficult things, but they are important. If the collision between the ball and the flow is perfectly elastic, draw the VT graph. Well, sketching the VT graph will be very simple. Collides, rebounds, comes back again, goes up, rebounds, then same height. Same height. Okay, now perfectly elastic collisions. Right. Moving on. A particle of 6 10 to the power 26 in an empty cubical box. Empty cubical box, cube. All sides are same. 1 meter length. 1 meter length. Here 6 10 to the power minus 26 kilogram. Side length 1 meter. The collisions between the particles and the walls are perfectly elastic, and the speed of the particle is 2000 meters per second. Speed of the particle is 2000 meters per second. Assume that the gravitational force on the particle is negligible. Calculate the rate at which the particle collides with one of the two walls. Rate. So rate means, let's say starting here, it will go there, collide, turn back and come. Rate means the frequency of collision. Rate means the frequency of collision. So here, time taken, distance is 2 meter, 2000 meters per second, 10 to the power minus 3 seconds. The rate at which the particle collides is actually frequency, 1 over t. 1 over 10 to the power minus 3 is 1000. 1000 hertz. Rate at which collision takes place is 1000 hertz. 1000. 1000 hertz, or we can say per second. Per second. Right. What is the rate at which the particle transfers momentum to the wall? Particle transfers momentum to the wall. Right. F is equal to mv minus mu divided by t. Momentum change, don't forget. Mass 6 10 to the power minus 26. Final velocity is in that direction. Okay. Final in that direction, 2000. Initial in the opposite direction. 1 over t is going to be 1000. 6 10 to the power minus 26. Change directions both in the same direction. 4000 times 1000. 24 10 to the power minus 20 Newton. 24 10 to the power minus 20 Newton. In other words, 2.4 10 to the power minus 19 Newton. Force. Force transferred to the wall. Force transferred to the wall. Right. Next one. Suppose that the box contains 2 10 to the power 23 such particles performing the same motion mentioned. Assume that these particles do not make collisions among themselves and that collisions are uniformly distributed over the entire area. Calculate the pressure exerted by the particles on one of the two walls. Now these are like an ideal gas equation. Particles are traveling without colliding with each other, right? So now let's find the total force. Total force. Total force will be one particle we know 2.4 10 to the power minus 90. So many particles. So 4.8 10 to the power 4 newtons. Pressure is equal to force divided by area. 4.8 10 to the power 4. Area is 1. Area is 1 meter square. 4.8 10 to the power 4 Pascal. Pressure exerted. Pressure exerted. Right. So these are your ideal gas equation. Now there are ideal gases like spheres. They are colliding with wall, go back, come back again. Colliding with the same wall. So it's going back, coming back again. Force transferred to the same wall can be found. Number of collisions are taking place per second or whatever, we can find and find the force. These from one particle. How many particles are there? 2 10 to the power 23. So total force can be found. Total force divided by area will give you what? Pressure. Total force divided by area will give you pressure. Okay, no? Right. Okay. Right. So this concludes today's work. So this is week 5. How much of work have we done? This is the work. 60 MCQs, 4 to 40 plus today's 20, altogether how much? 260 MCQs. 260 MCQs. Here. Structured essay. Structured essay. 3 times 4, 12, 12 and 1, 13 structured essay. Essay. 3 times 4, 4 weeks over, 12, today 1, 13 essays. So we have done 260 MCQs, 13 structured essay, 13 essays. That means there are 260 types of questions which you have experienced. 13 types of structured essay which you have experienced. 13 types of essays which you have negotiated and experienced. Okay, no? So make sure you use this experience when you move forward. By now, the ones who have been doing this program for the past 4 weeks would have realized your level has automatically increased slightly. Some questions, when you see itself, you know exactly what to do. Is it clear? So imagine after 4 weeks, imagine after 24 weeks what level you will be. Is it clear? So keep faith in yourself, keep faith in your ability, keep working, and guaranteed your hard work will always pay off. Is it clear? So therefore stay home safe, keep working. I'll catch you tomorrow with week number 5, day 2. Stay home safe. Good night.